Hello guys, welcome to the course of Programming Fundamentals. I am your resource person, Kifayatullah. In this course, I will talk about the programming fundamentals, the concepts which are required for programming in any language. But more specifically, I will be talking about Python. So there are going to be two streams. In the first stream, I will post a video lecture about the theoretical aspect of programming, while in the second, I will post videos related to the practical implementation or real programming in the Python language. So we are in the first week. Let us start the course. Here is a brief introduction about today's lecture. I will start from the objectives what you are going to learn at the end of this week. Then I will talk about problem solving and some problem solving techniques. And also we will shed some light over why programming give us the feeling that it is difficult to write computer program, and then how you can improve your programming skills, how you can become a computer programmer and not a coder. And finally, I will have some discussion, but obviously, I will leave this discussion about assignment in the practical class. So let us start the course. Here are the objectives. At the end of this week, I expect that you would be able to familiar with the course and also with some of the reference books which are available. I will not talk about them in the lecture, but I have mentioned them in the course website. More specifically, you will know about the field of computer science in general and also the software engineering. Then the most important thing is that you would be able to learn about problem solving techniques and how you can improve your programming skills. So let us start with the problem solving techniques. But before problem solving, to talk about the problem solving, I will shed some light over why computer science is the right field for you. Can anybody tell me how many computers are there in the world? You can post the answer to this question in the comments section and tell me what you expected, how what is the number of the computers in the world. And let me give you a hint that it is going to be more than the current population of this world. So we don't know, maybe in billions, right? Or another way to think about the number of computer is to think how you use different types of computer in your daily life. How many computers do you use? For example, when you wake up, you use a type of computer and that is like automatically switching off your light or switching on your light, automatically switch off your AC. And then when you go to the washroom, you can take a shower. So if your shower is intelligent or smart, it will adjust the temperature, it will let you how many water you require for taking a bath and things like that. Then you go to the kitchen and you use microwave, so that is also a type of computer. And then you go to your car or you take a bus to reach to the university, and they have plenty of sensors installed over in them, and they are also a type of computers which control the internal functions of the car or the bus. Then you use your smartphone, which is a type of computer. You use your MP3 player inside the bus or car to listen to music, which is an example of computer. You may use your camera to take pictures of different scenes or scenarios or things that happen on the way. That is also a type of computer. Then you use your laptop inside the university, which is also a type of computer. In it, you take the elevators, etc. So the list goes and goes. Obviously, we use more than 20-30 computers in our daily life. Almost everything we do that is influenced by the computing. So why we study computer science? Because the field of computer science is embedded in almost all aspects of our life. Let me tell you one thing. There's that today generation will not be surprised by this statement because they uh, born in an era where computers are there, where internet connection is there. Even a child of 2 year know how to use a cell phone, a smartphone in order to watch YouTube videos. So we are not surprised by the influence of the computer. But if you ask someone who born in the 60s or 50s or 40s, then for him or for her, these things are going to be like revolutionizing our life. For them, the situation is very much different. So the computer industry is one of the fastest growing segment of our economy, and it will promise to grow and continue to grow in the future. So now, computer disciplines, we have actually two type. There are different types of discipline, but the most important two are the computer science and software engineering. Computer science is actually a discipline which encompasses a wide range of topics ranging from theoretical aspect to algorithmic foundation and cutting edge development. So a computer science degree consists of courses that include computing theory, programming languages, mathematics, and some other basic science courses. These courses are designed in a way that will help you to develop your logical and reasoning skills in order to help you to become a computer programmer in a true sense or a computer scientist in a true sense. While on the other hand, software engineering is a discipline which focus on developing and maintaining of large software systems. In software engineering, we are interested in learning the system performance, how they behave, the reliability of the system, software system, the efficiency of the software system, whether they are affordable or not, or whether our developed software meet the requirements of the user or not. So the software engineering degree program is closely related with the computer science discipline, and they are actually offered under the same umbrella, like a computer science department can offer both of the courses, right? So, coming to the topic which is of interest, and that is problem solving. Understanding that problem is a key to a good program. Normally, we write computer program in order to solve our day-to-day problems. So, problem solving is a technique which we need to learn as a programmer. Understanding the problem is a key to a good program. So, the problem is that learning to solve programming problem is hard because learning the syntax and semantic of the programming language is the first step. But before that, we need to understand the problem that we are going to address or that we are going to solve. Our current programming education does not offer much guidance in the area of problem solving. They focus on the aspect of how to learn program, how to know the how to learn the syntax and semantic of the language, how to learn the tools which are required for programming, but they do not focus on the programming aspect, the problem solving aspects of the programming. So we need to focus on the problem solving technique as well, and that is one of the reason that I start this course with the introductory lecture which is focusing on problem solving technique. So problem solving is actually, we can define it this that writing an original program that will perform a particular task or set of tasks, and it will meet all this constraint. We will talk about the constraint in a moment. So beginning programmers are often so feel so discomfortable to accomplish the first part of this definition, problem solving. Normally, in the course of computer programming, we let the student sit in front of computer and play with the tools required for learning or for practicing the programming. But it is essential to make their mind about problem solving technique. For example, here are some classical problem problems And I am sure most of you will be familiar with these examples. The first one is a classical puzzle problem, and it is about a fox, a hen, and a bag full of grains. The problem is like this. We have a farmer, and the farmer want to cross the river. He also need to bring his belonging along with him. But the problem is that the constraint are here. The limitations are here. He can only carry a single item with him, either hen, either the fox, or either the bag full of grains. But uh, you need to solve the problem by keeping in mind the limitations of the problem. So this problem is actually a good example of the importance of constraints that we will be facing in our actual real world programming problems. So if we remove any of these constraints limitations, then the puzzle is easy to solve. Put all the items, put the hen, put the fox and the grain in the boat, and then cross the river. But we have limitations, we have constraints, and that are important. So the farmer can take only one item at a time in the boat. The fox and the hen, they cannot be left alone because the fox will eat the hen. Similarly, the hen and the grains cannot be left alone. If you left them alone, the hen will eat all the grains. So there is a problem. There are the constraints. So now you have the constraint, you have the problem, you need a solution, and then you have to think over the possibilities. You have to write down all the possible solutions, all the operations. For example, what if we carry the fox first? What if we carry the hen first? What if we carry the grains first? We have to think. So the solution is very simple. It's simple for me because I know the solution. Maybe it could be difficult for you if you don't know the puzzle. So I will left to you. You can think and come up with a solution. What is important for me is the lesson learned from this problem, and they are the important principle of problem solving. If you are unaware of all the possible actions you could take, you may be unable to solve the problem. So you need to think on all the possibilities and all the possible solution. We can solve many problems by testing every combination. Hey, what if we take the hen first? What if we take the grains first? What if we take the fox first? So you have to think on all the possible aspects while solving a problem. Many programmers seek out other programmers to discuss a problem. There is a lesson learned. You can discuss with your friend how to solve a problem that you are working on. We also have another classical puzzle problem, and that is sliding tile puzzle. I'm sure you have played one of such puzzle games in which you try to make a picture of some animal, some birds, some plants, etc. by randomly moving the slides. So here we have a 4 by 4 grid. It could be 3 by 3, 5 by 5, 6 by 6. So in case of 3 by 3, the grill is filled with 8 tiles, and they are like numbers or maybe pieces of the picture of some animal. Initially the grid is in a jumbled form. What you need to place each tile in the correct position in order to make the picture, or in the second example, to let the numbers in a sequence like 1 2 3 4 5 6 7 8 9. So the puzzle is quite different from the previous one, the farmer, the fox, and the hen and the grains. The difficulty in this puzzle is that you have to overlook on the possible operation. So the difficulty here is that the long chain of operation required by the solution before getting the number in a sequence, before getting the picture of the elephant, you will need to move the tiles back and forth randomly many times. So a series of sliding operations may move some tiles into the correct position, but maybe due to that move, other tiles will move to incorrect locations. So it's difficult to formulate a strategy, but still many people know how to solve this puzzle by some hints. So nevertheless, there are strategies for solving such type of puzzle. What are interested for us is that the lesson learned from this problem. The number of the tile movements is large enough that it is difficult or almost impossible to plan out a complete solution for solving the problem. So however, we can make a plane. We can make to plan a complete solution, and it will not prevent us from making strategies or different technique that could systematically solve the puzzle. If we compare it with programming problems, we are sometimes faced with situation where we cannot see a clear path to code the solution. But we must never allow this to be an excuse that, oh, this is a difficult task and we do not need to solve it. So you need a systematic approach to solve the computational problem. It's better to develop a strategy than to take the problem with trial and randomness or with error. So you need a strategy. Another lesson from this puzzle that would help us in programming is that sometimes problems are divisible. Like divisible in the sense that in ways that they are not immediately obvious. So when solving programming problems, working with a specific goal in mind is always better than random effort. That is the best lesson that we can learn. You need to think over the problem and on on the on the goals in your mind that will help you to find a better way to solve the problem rather than doing some random efforts to solve the problem. Another classical problem is that of the Sudoku, which is very much uh, common in newspapers and magazine, and this is actually a logical based number placement puzzle. For example, we have a grid over here. I think the grid is 9 by 9, and the grid is partially filled with single digits from 1 to 9. So the game is like this. The puzzle is like this. The player must fill the empty squares while meeting certain limitations, certain constraints. And the constraints are like this. In each row and column, each digit must appear exactly once. Furthermore, in each 3 by 3 marked area, each digit must appear exactly once. So you have now limitations. What do we learn from this Sudoku puzzle? The main lesson from the Sudoku is that we should look for the most constrained part of the problem. While constraints are often what make a problem more difficult to begin with, they may also simplify our thinking about the solution because they eliminate certain choices. So that is the main lesson that we could learn from Sudoku puzzles. So now problem solving techniques. Here are some tips that if you follow them, you would be able to solve critically and solve the problem in an efficient way. The first one is always have a plan. This is very simple. How would you plan a trip to a certain city? You have to think on the different options that you have available, right? Like whether you are going by bus, by car, by train, by plane, etc. Similarly, you have to check the weather conditions over there, hotel reservation, and the tourism spots in that city. So when you have an original plan, then the things are going to be to work in an efficient way. Without a plan, you are simply hoping for a lucky break. Just like there is a theorem which is called the random monkey. The theorem is like this: if you allow monkeys to type the letters on a typewriter and they have infinite time, then one day they would be able to type the Shakespeare novel, complete novel, randomness. But here you have infinite time. But in programming, we don't have infinite time. We have certain limitations to solve the problems. So in that case, you must come up with a plan to solve the problem. Without a plan, you have only one goal, solve the whole problem. But with plan, you actually have different strategies for solving the problem. Similarly, you have to restate the problem. You have to, if the problem is difficult for you or you think you are not able to solve the problem, then in some cases a problem that look very difficult may seem very easy when it is stated in a different way or when it is approaches from a different angle, or when you use different terminologies, different terms, different concepts, different when you think on different aspects. So restatement can be a powerful technique, but many programmer, they actually skip it because it doesn't directly involve writing code or even designing a solution. This is another reason why having a plane is essential. Without a plane, your only goal is to have working code, and restatement is taking time away from writing the code. With a plane, you can put formally restate the problem as your first step. Therefore, completing the statement, the restatement officially counts as a progress. So, another tip is that you must have to restate the problem if it is not working in the current scenario. You have to restate it. And then another approach is that you can actually divide the problem into sub-problems. Dividing a problem into steps or phases can make the problem much easier. If you can divide a problem into two pieces, for example, you might think that each piece would be as half as difficult to solve as the original problem. But usually it is even much more easier than that. Working on a small part of a problem is actually much more easier than working on the whole problem at once. And then start with what you know. And with time, you will enhance your programming skill. So when programming, you should try to start with what you already know, how to do, and work outward from there. Once you have divided the problem into pieces, for example, go ahead and complete any piece. You already know how to code. And then gradually you have to move to other pieces. So having a working partial solution may spark ideas about the rest of the problem. So it is important that you start with what you know. In this way, you also build your confidence and momentum towards the final goals. Also, you can reduce the problem, the size of the problem, or the scope of the problem, either by adding more constraint or by removing constraint. So reducing the problem has enough in common with the full problem. This is also related with dividing the problem. Like for example, if your program is the objective of the program is to convert 1000 number into ascending form. So it is better to start with two numbers, how you can sort two number, and then gradually increase, how you can sort five number, how you can sort 10 numbers, and then you will see that the problem will become the problem of solving 1000 number or putting them in an ascending form will become much more simpler to you. Also, you need to look for analogies like similarities between a current problem and a problem that already solved. So what is similar in the current problem and what is similar in the problem that you have already solved? The similarity may take many forms. Sometimes it means the two problems are really the same problem, or the technique are used in the two problems, they are same. So analogies recognition is the most important way you will improve your programming speed and skill at problem solving. It is also the most difficult skill to develop, by the way. For example, you have to compare apples with apples and oranges with oranges. Analogies doesn't mean that you have to compare the apples with the oranges because they are different, right? So this is a skill which need to be developed. And then experiment. Sometimes the best way to make progress is to try things and observe the results. The experimentation is not the same as guessing the solution of a problem. So you need to test, test, and test. Whatever you see, whatever you hear, one day you will forget. But whatever you try, you practice, you experiment is forever. You will never forget it. So learning is by doing, by experimentations, by practicing, by testing. So an experiment is a control process. Your hypothesis that will happen when certain code is executed. Try it out and see whether your hypotheses are correct or not. And then don't frustrate. This is an advice. When you are frustrated, you won't think as clearly, you won't work as efficiently, and everything will take longer and will seem harder. So the frustrated programmer isn't angry with the source code on the monitor, although the programmer may express the frustration in those terms. Instead, the frustrated programmer is angry at himself or herself. When you allow yourself to get frustrated, you are giving yourself an excuse to continue to fail. So, avoid frustration is a decision you must make. Even if you fail, you need to retry. Sometimes failure is good for success, right? And once you make a mistake and then you correct the mistake by yourself in the future, it will help you to avoid such mistakes. So don't frustrate if you make some mistakes. So not everybody is programmer. You can learn coding, but programming is something different from coding. Why the difficulty of the computer programming is a difficult task? Why doesn't everybody do it? Why doesn't everybody is a programmer? So let us start with the poetry, and it is from French. Actually, when you try to learn a new language, you are actually dealing with two different things, specifically the poetry. So two things at once. For example, the first one is a poetry from French. If I suppose I assign a task to you, and the task is you need to translate this poetry into English. Let us assume for the moment that you do not know the French language and you have never studied poetry. So you have two problems, French language and the poetry, the syntax of the poetry. So you have two problems on your hands. First, you have to gain a better understanding of the syntax and semantic of the French language in order to understand the poetry, right? And second is you need the rules about the poetry. What constitute a good poem in French? So what's your first move if I want you to translate this to English? Many people will use a translator. So the second, the green, is the translated version of the French poem. You see, my sweet, cute, I, you, give, convey the good day, blah, blah, blah. So this is a translation word by word, but it is not as much meaningful as the third one, which is in the red color. So this translation doesn't capture the syntax and semantic, but not, it actually does have syntax, semantic, but not the poetry shape of the original poem. So not only the second translation version sound more like poetry, but it also matches the original poem which is in the French. So now compare the poetry to the programming. Actually, the analogy is pretty strong. In coming to programming for the first time, you face exactly the same issue. You are not familiar with the syntax of the language, programming language, for example, Python. You are not familiar with the semantic. You are not familiar with the tools of the programming language you are working with. Similarly, you do not know how to solve problems using a computer. Similar to not knowing how to write poetry. You do not know how to write programs. Okay, so there is the analogy, and that is why computer programming is a bit hard, because you are dealing with the two things at the same time. So working at two levels, the meaning of the programming words and then the intent of the program, what the program is trying to solve, are two different problems the beginning programmers has to face. So some tips is that the way to learn programming is to program, is to write program, is to practice program, is to experiments with the program. And learning is best done by doing. So you have to write programs in order to learn program. Now we have a question that what is actually a good program? So the first thing come into mind is that anything which solve our problem is a good program. So it must solve the problem for which it is designed. But efficiency of the program is also important. How efficient your program is, how efficiently it solves the problem. So having mastered some of the syntax and semantic of a programming language, how do we write a good program? Well, programming is actually all about thinking. It's all about problem solving. So we can take another analogy. Here we are going to compare the program with a human readable essay. For programming, it is all about problem solving. Okay. But the program uh, is like a human readable essay. When students are asked what is the most important feature of a program, many would answer it should run. By run, they mean that the program executes and actually does something wrong. This is wrong. As with any new skill, it is important to get the fundamentals correct right at the beginning. So a program is an object to be read by another person, just as any other essay, just as any other newspaper article. Although it is true that a program is written in such a way that a computer can execute, but still it need to be a human readable essay. And why it is important? Because uh, the question is like this: why should it be that people must read your program? If your program is readable by the computer, if it is doing what is expected to do, okay. But for us, an efficient program is not like that. It must be read by people as well. But why? Why isn't running good enough? Why? Who is going to read your program actually? So the person who is going to read your program is actually you. That's correct. You have to read the programs you are writing all the time. Every time you put your program away for some period of time and then you come back to it, you have to reread your program that you have wrote, and you need to understand what you were thinking, what you were working, what you have written. Your program is actually a record of your thoughts on solving the problem, and you have to be able to read your program in order to work with it, update it, add something to it, extra features, etc. Beside from yourself, there are other people's. If your code is open source, there are other people who are going to read your program, who are going to extend your contributions. You will be writing program for other people's or for other groups of people or programmer. So your program must be like a human readable essay, and that we consider a good program, which is readable by yourself and by other programmers. So our goal is to write programs that other people can read and they can understand and they can run and they can extend actually. So that is going to be a good program. Now, finally, let us talk about how you can improve your programming skill. Programming is a difficult task, right? Which requires lots of practice. So the first tip here is, in order to improve your programming skill, you need to practice. As we know, a program is an essay on problem solving. However, still, it is interesting that programs do indeed run on a computer. In fact, the most impressive part about a program is that it must be understand, it must be efficient, it must able to solve the problem for which it has been designed. And for that you have to practice. You have to solve the real world problem by doing practice. The best way to improve your programming and problem solving skill is to practice. Learning to program for the first time is not all that different from learning to kick a soccer ball or play a musical instrument or hit a ball with a bat. So all things require practice. Similar is the case with programming skills. Programming are problem solving skills. It is important to learn about the fundamentals by reading and talking about them. But the best way to really learn programming is to practice. If what you type in the first time doesn't work, who cares? Try again. See if you can fix it by yourself. If you don't get it right the first time, you will eventually learn things. With time, you will improve your programming skills, but only if you practice. Experimenting is an important skill in problem solving. So writing program is necessary to master programming skill, and practicing them is important to be able to improve your programming skills. The second programming skill The second tip that you can use to improve your programming skill is to understand and then visualize. You cannot solve a problem until you understand it. So the first thing is to understand the problem on which you are working. Often, a problem start is a simple statement. We want to create, for example, a horseless carriage, a mode of transportation that does not require a horse to get around. So designing an automobile, which is what a horseless carriage, is for the first time difficult, but now it is not difficult anymore. No one has ever seen one horseless carriage before, but now everyone can see them around. We have different type of vehicles which do not require a horse but an engine. So understanding the problem is important, and then visualization come. So we use strategies, therefore, to address the problems. For example, in our problem similar to others, hopefully solved problem, you can compare them in order to understand or get a better idea. So with computational problems, ask yourself whether there are similar problems with known solutions. In software design, they are also called the patterns. So you have to look for the patterns, similarities. For example, I'm giving you a problem, and the problem is like this. Hey, A is greater than B. Write a program for it. And then you know, oh, I know the program for A is less than B. So the two things, the problems are different. In one, you have to find the largest. In the other, you have to find the smallest. The logic is very same. Only you need to change one operator. But where? Okay, so that is you need to think, you need to understand the problem, and for that you have to ask yourself whether there are any similar problems that you have worked on. If the problem is something you have to post, finding a way to phrase the problem exactly can help. It is also advisable to write an algorithm for solving the problem, and then you can convert the algorithm to a computer program. But as you doesn't uh, know about the concepts of algorithms, so maybe the third semester you will take a subject which is called data structure and algorithm, and there you will develop your algorithmic skills. So often there is a best practice to write an algorithm before writing the actual program. And for understanding the problem, you need to think about other things like what are the inputs, how to test the inputs, what is going to be the output, how we can process the input, what is the expected result, what are the output that are more appropriate, what is a similar problem, etc. So you need to understand, for understanding you need to think over all these aspects, and then you need to visualize, making the problem a real problem. For example, if the problem is to write a program that plays a card game, now is the time to pull out a deck of cards and give it a try. You don't know how to play card games, then how you would be able to write a program for it, right? So you have to make the problem real. Some other types of problem include, for example, some strategies that you can adopt before coding is that you need to try with simple examples by using pencil and paper. Work some example using objects, for example, playing cards or toy cars if your program is related with the vehicles. Draw some graphs, draw some flow charts, create diagrams of the interactions, brainstorming sessions. Can you visualize the problem in some way to make it more real to you? You have to think on it. If so, it will give you better insight into the problem. By making the problem real in some way, you can play with the problems and get better understanding of the problem. And also you need to think before you program. So in the beginning of this lecture, I emphasize on the problem solving technique, and problem solving required thinking. So it is still important that you understand the problem before you program, and for that you need to think over the problem. Often um, programming while you are trying to solve the problem leads to condition which is called the dung ball programming. So I will not go into the details, but the main point here is that you need to think, and you need uh, to think on the problem in order to solve the problem or find a solution. And then, as we talked, experimentation is important. And for experimentation, the suggestion is that instead of trying to write the whole program from beginning to end, try out some strategies. You can divide the problem, you can work on simpler problem, and then you gradually add complexity. So experiment with the code and then simplify. If you cannot solve a problem directly, perhaps an easier, more restricted, focused on some particular aspect of the problem of version of the problem exists which you can solve. What simplicity mean is that first you need to work on simpler problem, and then you have to gradually add complexities in order to achieve the final goal. And you will see that it will be much more easier to work on the simpler versions of the problem. So the smaller problem will be more manageable, and hence they would be more easily solvable by you. In fact, you may find the whole problem totally unsolvable, but yet each piece of the software that you have divided, it could be easily solvable. So having solved the smaller pieces, then you need to assemble them into overall solution, and then you would see that it would be much more easier. So by breaking the problem down into simpler problem, you accomplish actually two different things. First thing is that psychologically you make the overall problem more traceable. Rather than starting at the larger problem, you actually work on a smaller version of the problem. So you can start by solving smaller, simpler pieces and then moving on. Success breeds further success. Also, smaller pieces usually are simpler to approach. And secondly, by solving this smaller problem in isolation, you can solve them better and more completely. You know about OSI, about the OSI model is a layered approach. So the advantages of dividing a problem into sub-problem is that you actually focus more on the smaller problem. You can actually find better solution for the simpler and smaller problem, and then when you combine them, your whole efficiency will also increase. Stop and think. At some point in the middle of this process, thinking, experimentation, understanding the problem, writing the code, in the middle of this process, you need to stop and look at what you have done so far and evaluate yourself, evaluate your results. It might be that your skeleton is not coming to life as you had adopted, as you had hoped. You might have started down a problem solving path. Now that you are further along, seems like a poor approach. Now, you need to be willing to throw something out of if it isn't working. Avoid this approach of carrying the wrong path. Sometimes you put some effort in a problem, and then in the middle of the process you realize that you are on the wrong track. You are not going, you are not moving, you are not progressing toward your goals. So this is a hard decision, but you have to throw away this progress, although it will help you in the future, but you are on the wrong track. So be brave and be willing to throw the bait part away and do the right things at the right moment, right? So you have to stop if the things are not working, and then you have to think on alternative solutions. What if I adopt the second approach, right? If you are not leading towards the goals, it's time to stop and rethink over the alternative possibilities and solutions, and then relax and give yourself a break. Sometime you get fed up with doing programming in code and sitting all the time in front of computer, in front of monitor, playing with the words, with the games of the words. So if you work long enough at a difficult problem, you are likely to get stuck at some point. So what to do now? How do you unstick yourself? One of the best approach is to walk away. Let it go for a while. Take a breath and come back when you are fresh, when you are relaxed, when you have enthusiasm. So letting a problem sit is a way to relax and look at it with fresh eyes and fresh mind later on. Having broken down the problem into smaller pieces make this step easier. Reconnecting with a similar problem is easier than with a larger problem. Also, you may be able to work for a while on a different piece of the puzzle. What I'm trying to say is that if you stuck at some point, put it aside and then work on the second piece of the software, second problem, the second piece of the problem. It's possible that the second piece is more interesting than the first one, and then come back to the first one after some time, after a break, right? So in this way, you can improve your programming skills. These were some some tips for the beginners programmer. I hope you would learn something from this presentation. In the next lecture, we will be talking more about the programming fundamental concept. So this was for today's lecture. See you in the second week of programming fundamentals. Till then, bye.